Pete Sturdevant, application engineer at Ralph W. Earl Company. MIR is part of a family of products called AMRs, Autonomous Mobile Robots. They have a MIR 100, a 250, a 500, and a 1,000. All of those numbers correspond to the payload in kilograms that they can haul. So these, as opposed to an AGV, don't need anything to tell them exactly where to go, right? An AGV generally has some kind of track system in the plant that it's following. These don't have that, they're completely autonomous. And the big benefit to that is, if something gets in an AGV's way, it just sits there and doesn't move until that thing's out of the way. Whereas these, since they don't have a track system and they can figure out their own paths, when something gets in its way, it just figures out another way to get to where it wants to go. On each of these robots, they're gonna have 2 drive wheels in the center, kind of like a bulldozer, and then casters on the corners. So that's how these things are able to drive around in a real tight circle like that. On those 2 drive wheels, there's encoders on both of those, so they're able to track the positions as they're going. It's also got laser scanners in 2 of the corners that allow it to have a 360-degree view of everything 8 inches off the ground. And then in the front, you'll see 2 3D cameras kind of pointing up at angles, and that allows the robot to see, things up at elevation. So if there was something overhanging, it knows not to run into that because of those 3D cameras. You bring it into your factory, you drive it around manually. It's taking in all the data from those encoders, from the laser scanners, from the 3D cameras. It takes all of that in and creates a map. That map is shown on the screen up here. The white areas on that map is what it's identified as floor. The black areas are what it's identified as like a permanent fixture, a wall. All of the red stuff on there is current laser scanner information. Purple is like a safety area around all the things that it sees with those laser scanners, so it knows not to hit those. That robot created that blue dotted line. That's the path that it is going to try to use to get to this part. Something happens, somebody gets in the way of it. It recognizes me. You can see my feet, the little red dots, and it created a new path to get to where it wants to go. Part of that mapping process is also like creating positions that you want the robot to go to. So those are shown in the bigger blue dots. You then need to create missions. A mission is a program that the robot will execute when somebody calls that mission. Typically, what you would have is somebody pushing a button on an operator station requesting more parts. There could be a little tablet with a display on it. They're requesting a robot as well. Or it could be a higher level where it's coming in from like an ERP system telling the robots what to do, calling those missions. There's the robot itself that just drives around, but you need to be able to like hook onto something or transfer parts or actually do something when you get to that location. We call those top modules, those kind of accessory products that allow the robots to actually move things around, grab things, transfer things. So on the 250, the smaller model, that's got a top module that just has a couple of pins in it that's going to interface with that cart. So right now you just saw those pins come up and it's able to drive away with that cart, go to the position where it wants to go to and drop them off.